This is Algebra 2, Section 1.3 notes. That's all about functions. So first of all, we have to start with a couple of basic definitions. A relation, oftentimes you'll hear a relation or a function, okay? And they are different. They're related, but they are different. So a relation is simply a set of ordered pairs, okay? A set of ordered pairs. And it doesn't matter what those ordered pairs are. You might have more, an x that goes to two different y's. You might have a y that goes to two different x's. It doesn't matter. Okay, a function is a relation. So it is a relation, which means it is a set of ordered pairs. But the key to what makes this a function is that every x can go to exactly one y. So every x value is paired with exactly one y. If it's more than one y, then it's not a function. It might still be a relation, but it's not a function. So if you look at the first example here, it says this is not a function. I'm sorry, it says this is a function. Notice every x value, the 1, the 2, the 4, and the 5, those are your x values. Each one of those is paired with exactly one y value. So it is a function. But look at the second example. Your x values, you've got 1, and then you've got 4 twice. And then you have a 5. Well, do you see how the 4, in one case, it's paired with a 2, and in another case, it's paired with a 3. So you have an x value that's paired with more than one y value. So that's why we say this is not a function. Okay, so basically I just answered that question. So determine whether each relation is a function. Well, you always start by looking at the x values. I have 9, 5, 5, 3, and 0. Well, do you see that in this case the 5 is paired with a 3, but in this case the 5 is paired with a 1. So that means you have more than one x value. I'm sorry, you have one x value that's paired with more than one y. So it's not a function. Look at this one. Notice your x values, 3, 2, 0, -1, -3. You have all different x values. They each go to exactly one y value. So this is a function. Okay, now this one's a picture. Now we do need to kind of make sure we agree. We'll say these are the x values and these are the y values. So a lot of times people will be confused because they'll see, hey, look, the 2 goes to the 5, but the 4 also goes to the 5. But that's okay, because if the 2 is an x value, it goes to exactly one y value. The 4 is a different x value, it goes to exactly one y value. It's okay that they go to the same as long as they go to exactly one y value. So this is still okay. This is a function. You may remember talking about these back in Algebra 1, and it's easy to tell if something is a function if you have the graph, because you can use the vertical line test. If you can draw a vertical line, okay, anywhere on the graph, and if it only hits the graph one time, notice this vertical line hits only one time, this vertical line hits only one time, this vertical line hits only, so it's okay to hit one time, but if you draw a vertical line and it touches the graph more than one time, then it's not a function. So this one is still a yes. This one may seem like it's a vertical line, may seem like it's a function. If you draw a vertical line here, it's only going to hit one time. But do you see, if you were to draw a vertical line right through here, do you see that it would hit the graph 2 times? It hits right here. It also hits right here. So all it takes is one example of a vertical line touching more than one time, and it is not a function. Okay, so that's how you tell if something is a function or not. Probably what we use a lot more often. I guess the previous, you use this on ACT, SAT, it's always a question, how do you know if it's a function? And usually it depends on the vertical line test. But on this one, we use this a lot, using function notation. And again, I know you started this back in Algebra 1. So we have a function, it's called f of x. That's the way this is read, f of x. We say that f is the name of the function. It could just as easily have been a different letter. It might have been h of x or f of t or g of x, any of those variables can be different, but it's the letter on the outside that's the name of the function. And then the actual f of x itself represents the y value. It represents the y value if you're talking about a graph. And we say the output because usually the idea is x is the input, and then whenever you put in an x, what you get for your answer, is the y value, or that's called the output. So what you learned about function notation here is, since the 2 is on the inside, that means this represents the x. So what this is saying is, go up to your f function, since this is titled f, and this is titled f, and put this number in place of x. Everywhere you see an x, you're going to put that number. So you would say, well, f of 2 is going to be not x squared, but 2 squared, minus 2 times not x, but times 2. So that just means substitute in a 2 everywhere you see an x. Now, yeah, you could simplify this and say, oh, 4 minus 4 is 0, but I'm not as concerned about the answer as I am the idea of knowing what function notation means. So in the next example, you could say, all right, great, I'm going to put a -3 everywhere I see an x up there in the f function. So it's going to be -3 squared instead of x squared, minus 2 times, not x, but -3. Again, that right there is the most important part. And then, of course, if you want to simplify, let's see, that turns into 9 plus 6, which is 15. Okay, so yeah, you can simplify, but I want you to understand what function notation means. So look right here. What if it's a 2x? Well, that's fine. That means you put whatever this parenthesis is, the entire 2x, everywhere you see an x. So instead of this x that's squared, it's going to be a 2x that's squared. If I can write that so you can read it. And then it's minus, not 2 times x, but 2 times, what are we putting in place of 2x? I'm sorry, in place of x, we're putting in 2x. Again, that's the most important part. If I want to simplify this, let's see, that's going to be 4x squared minus 4x, and there's nothing you can do with that. Okay, in this case, it says put a negative x in place of x. So instead of x squared, it's negative x that's being squared, minus 2 times negative x. And of course you can simplify. If I square the negative, it's going to become a positive x squared, and then plus 2x, and that's all you can do. Now look at letter E. Notice how letter E is different than letter D. On letter D, we were putting this negative x in place of x because that's what was on the inside. But notice on letter E, the negative is not in the parenthesis, it's out in front. So it means, hey, leave that negative, and now in place, and now this f of x is, remember, if I can get rid of all my scratch work, remember up here, what does f of x equal? Well, f of x equals this whole thing. So if I want negative of the entire f of x, that means I want negative of the entire x squared minus 2x. Yes, of course you can distribute the negative, but that's what's important is the setup here. So if I distribute the negative, I actually have negative x squared plus 2x. Okay, letter F, does that mean add 2 to the entire f of x? No, that means put this parenthesis up here everywhere you see an x. So it's going to be the parenthesis squared minus 2 times the parenthesis. And again, if you want to do the algebra to multiply that out, that's great. But what I have written there right now, that's the most important part. If I just, want to multiply it out, if I square the x plus 2, meaning if I do, x plus 2 times x plus 2, right? I'd have to do FOIL. It's going to become x squared plus 4x plus 4. And then over here, I'm going to have minus 2x minus 4. So notice in this case, those 4's are going to cancel out, right? Positive and negative. So what we're going to end up with is x squared plus 4x. Whoops, actually, why don't I go ahead and combine the plus 4x and the minus 2x, and that would just become a plus 2x. So yes, that's the simplified version But remember what I said, this setup is the most important thing that we're looking at. Okay, so that's how we do function notation as far as the algebra behind it. So now let's talk about kind of the graph. What does that mean on a graph? Well, remember, whatever is in the... Okay, those are my dogs, sorry. Okay, so remember, whatever is in the parenthesis is your x value. So in other words, this 0 that's in the parenthesis, that's your x. So if I look on the graph, this is the x-axis, go to where x equals 0. That's going to be, if you can see my cursor, that's going to be all along the y-axis here, right? That's where x equals 0. Well, where does that hit the graph? Well, that hits the graph right here. And the y value there is -2. So remember, f of x means what is the y value. So this is saying, what this is actually saying is that there's an ordered pair on this graph of 0, -2, right? Because the 0 is in the parenthesis, that's your x. The answer to the f of x is -2, that's your y. So if I look at the next one, this is saying that it's the x that is 3. So go to where x equals 3, that's right here, right? That's where x equals 3. See where that hits your graph, which will be right here. What's the y value there? It looks like it's -4. Okay, same idea, letter C. The x is 8, so go to your x-axis, see where x is 8, and actually that's right along here, and it looks like the graph doesn't touch that, right? So what we would say is it's undefined. If there's no answer, you just say it's undefined. Okay, so letter D is asking us to go the other direction. It's saying f of x equals 0, not x, but remember f of x is the same as saying y. So what this is saying is y equals 0. Well, when on the graph does y equal 0? Well, doesn't y equal 0 anytime you're on the x-axis? And so this is saying if y is 0, meaning if you're on the x-axis, then what is the x value? Well, I see several times the graph hits the x-axis here and here and here. So I think there are 3 x values, -5, -3, and 6, at which the y value is 0. Okay, and letter E, if the y is 4, remember f of x is y, so if y is 4, go up to where y is 4, that's going to be right up here. So think about y equals 4 all along this line. Where does that hit the graph? Doesn't that hit the graph right here? And so the question is, what's the x value? Well, if you follow that down, it looks like the x value would be 7. Okay? So you just got to think x value and y value. All right, so look at number 3. So this is a graph of f of x. And notice what I've put up here in the directions. There could be no answer, so you might say undefined, or there might be only one answer, or there might be multiple answers. Okay, so letter A, is it a function? Well, since I'm looking at the graph, I think about the vertical line test, and it doesn't look like there's anywhere I could draw a vertical line and have it touch more than one time, right? So that means yes, this is a function. What are the x-intercepts? Well, remember, x-intercepts are where it hits the x-axis, so there, there, and there. So I think the x-intercepts are going to be at -2 and 4 and 8. I could have written those as ordered pairs, right? I could have said -2, 0, or 4, 0, or 8, 0. Letter C, what are the y-intercepts? Well, remember, that's where it hits the y-axis, so that would be at y equals -3. Again, if I had written this one as an ordered pair, it would have been 0, -3. Just to give you an example, up here, if I had written these as ordered pairs, it would have been like -2, 0, and so on. Okay, so letter D, f of 3. So which one is 3? Is it the x or the y? Well, whatever's in the parenthesis, remember, is your x. So go to where x is 3. It looks like x equals 3 right here. Where does that hit my graph? I'm going to say that's right here when y is -2. Letter E, When is x 0? Well, remember, x equals 0 on the y-axis. That's the point down here that we've identified as the y-intercept, right? Which was when y was -3. So this is the same as the y-intercept. Okay, I'm going over here to f. If f of x equals 3, so what are they saying is 3, x or y? Well, remember, this is saying if y is 3, then what is x? Well, go up to where y is 3, right? That, kind of imagine the entire line here when y is 3. Where does that hit the graph? Well, doesn't that hit our graph 2 times? Not only here, but also here. So aren't there 2 x values? Either x is -3 or x is 6. So both of those x values, y is 3. Letter G, what if y equals 0? Y equals 0. Well, remember, doesn't y equal 0 on the x-axis? So hey, aren't those just our x-intercepts? And didn't we say we had 3 x-intercepts? They were, what, -2 and 4 and 8. And then letter H, if y is 5, so if y is 5, so that's up here, right, all along this line, if y is 5, then what's the x value? Well, notice when it hits the graph, can you see right there, it shows that there's a hole. So what that means is it doesn't actually touch that line. So basically we're saying y is never going to be 5. So in this case we would say undefined. Okay, one more example. So this one we're calling g of x. So that's fine. Doesn't matter what we call it, right? G of x. So g of 2 means what if x equals 2? Okay, this is a good one to look at. It almost looks like, here's where x equals 2. It almost looks like there's 2 points. But remember, this is an open circle. That means there's not really a point there. So this is the only actual point when x equals 2, and the y value there is 3. Okay, g of 0, well, remember x equals 0, that's on the y-axis. So wouldn't that be 1? And then this one is saying if y equals 0, okay, y equals 0, that's the x-axis. I think, aren't there a couple of those? Here's where it hits the x-axis, here's where it hits the x-axis, here's where it hits the x-axis. So I'm thinking -1 and 4 and 8. And then letter D, when does y equal -2? Well, here's -2. Okay, if I go this direction, there's a hole, so that's not a real point. If I go this direction, it looks like y is -2 right there when x equals 7. Okay, so that's section 1.3 on functions. Good luck with the homework.